So welcome everybody to today's multi-tenancy working group meeting. Thanks for attending. Our agenda today. First off, congratulations to Sanjeev Rampal, who is our new co-chair of the multi-tenancy group, along with me, Tasha Drew. Thank you, Sanjeev, for stepping up, and I definitely look forward to working with you.
Thank you, Tasha. Thanks, everyone. Look forward to working with everyone and helping this continue to progress on this group.
Cool. And then the agenda for today is Yushiro is going to talk about core dumps and multi-tenancy, and then Kural is going to talk about a tenant resource quota feature request / proposal. So Yushiro, would you like to take it away?
Okay, so hi, nice to meet you. I'm Yushiro, okay? Can you hear me? Is it okay? Okay, so thank you. So today I, Yushiro, and Ban-O Ishii and Wan-chan will present some explanation about our core dump feature with multi-tenant Kubernetes environment. So just a moment. Wan-san, could you continue to explain our core dump feature?
Oh, yes.
Yes. I will share my display.
Okay. So just a moment. Ban-O will share our some document for explanation. Just a moment, please. Okay.
Can you see this?
Yeah, I can see.
Okay.
But just a moment. A little unstable. Just a moment.
Are you okay?
Yeah, I've never seen that before.
Yeah, like just
maybe exit presentation mode and just show the browser.
Yeah. It's way for Ban-O, please stop the presentation mode and just explain with some normal mode. Yeah, I think it's.
Is this okay?
A little, yeah.
Yeah, I mean, I guess we can see most of it. Okay. Yeah.
古川さん大丈夫ですかね。
上の方がちょっと点滅してますけど、ある程度見えるんで。
本当ですか。
はい。
Yeah, sorry. Let's explain. We will explain automatic core dump collector feature. First, I will briefly introduce this feature. First, motivation. In multi-tenant Kubernetes cluster, only cluster administrator can access core dump files, but tenant administrator, workload developer, operator cannot, because dump file is stored on local storage node on worker node. So, to access core dump files created by container, tenant user should ask cluster administrator to fetch dump file and pass it to client user. So, to facilitate investigation of crashed application by tenant users, we are developing this feature. Yeah. And this automatic core dump collector feature stars dump file to remote storage, not local storage, and authenticate and authorize users access to dump file. So Next, from Wan-san, he explained how this feature works. One, please.
Okay. Hi, everyone. Page 2 shows the architecture of our design. Basically, there are 3 parts: the coredump files generate part, the coredump file download part, and the backend storage part. The coredump file generate part would launch an admin pod to those nodes with coredump labels. The admin pod would do following things. Firstly, it would copy an executable file called handler to the host file system. Then it would modify the core-pattern file on host to make sure the kernel would invoke the handler to copy an executable file called handler to the host file system. Then it would modify the core-pattern file on host to make sure the kernel would invoke the handler we just copied when job crash happens. The download part registers the aggregation API to master. Tenant could not access backend storage directly. They must download the core files by our aggregation API. In this way, we can implement access control with existing design like RBAC. The backend storage is simple. It stores all the coredump files generated by any pod inside the cluster. Next page. Hi. Ishii-san.
Hi.
Next page.
I think this is next page about what happens when coredump happens.
Okay. When job inside pod crash, kernel on worker node would generate dump files and pass it to our handler according to content of core pattern. Handler deals with coredump files and stores it in our backend storage. And when tenant wants to download coredump file, they could access aggregation API like any other original APIs in Kubernetes to get the coredump files they want. Administrator could control this by existing authority design like RBAC.
Next slide.
Yeah, next page. And the last page shows the administrator could choose which nodes support coredump features by labels, and whether admin pod is deployed on worker node who has coredump capability is determined by node selector field in pod spec. And this is all the current design of our coredump features in Kubernetes.
So this is interesting. Yushiro is sorry. Did I?
Yeah. I can hear you. Okay.
Could it also? So great. Thank you for bringing this to the working group.
You're welcome.
So a couple of basic questions on sort of just the feature positioning.
Yep.
Could it have been implemented by, instead of pushing the coredump file to remote storage and then providing access credentials, could it have been to simply provide a limited access directly from the host storage, like a privileged container that has access to the host local storage, but uses the credentials of that user or that namespace to allow retrieval of that core dump from the local storage directly into the Kube API without needing to push it to a remote storage. I mean, I'm just trying to understand whether this could have been done without needing to push it to a remote storage as an intermediate step. Is my question clear? Or, I mean, I'm just trying to understand the positioning and kind of architecture of the feature, and I'm wondering whether it could also be done by simply pulling it from local storage but controlling access.
Mm-hmm. Yeah. Yeah, I think you're right. So just tenant user can send us some API for after that. Yeah, okay. Once yeah, I
Yes.
think it's correct. So, what do you think about that? And okay. By the way, Sanjay, yeah, it's okay.
When we design like this, why we design like this? Because if we put the core dump files in host, it's like the when pod shifting between nodes, we think maybe there will be some problem. Like a pod running in node A at first, and it rescheduling to another node, and so we maybe have both node A and node B the core files. So we think this is not good.
Okay, maybe we want to dig into that a little bit more. Okay, firstly, could you please add this document to the working group link document page so that we can look at it without flickering and have more time for the working group to think about it and provide further comments.
Okay. So thank you, Sanjeev. So after finishing this meeting, we will upload this slide into some Google Drive or somewhere, and we can refer this slide with no ranking. So yes, and so Wan-san, could you paste this your URL for GitHub repository and some just a moment. Yeah, core dump detector and this issue. Could you paste the link something? Yeah, thank you. Yeah. Ishii-san, I think it's okay to stop the sharing your screen, so because a little yes, ranking. So yeah, thank you.
So I think it needs a little bit more review by the working group. I mean, is the remote storage the right option, or should it be just one of multiple options?
Mm-hmm.
So maybe we can all provide comments once you have put the document in the Google Docs and provide the link. I think.
Okay.
So I think have you already started prototyping the CRD for retrieving the core dump files and so on?
Yes. Sorry. Sanjeev, sorry. Could you say it again?
Have you already prototyped the controller in the CRD for retrieving the core dump?
Yeah, we are just now trying to implement, so that not finished yet. Maybe some 60% for, so that not finished yet. But and now, so Wan-san, how is your implementation right now?
What?
And so your coredump detectors implementation status.
Like 70%. 70%.
Mm-hmm. So that now you are writing, right?
Yeah.
Okay, so the Sanjeev, so as he explained, so that we don't have any moving some code right now. So now we are just under implementation.
Yes.
Okay.
So how does the administrator know what RBAC to put onto the core dumps? Because in any given namespace, like there could be lots of different people or groups or service accounts that have different levels of access. How does the administrator know who should be able to get to core dumps?
Okay.
You mean the access control?
Yes.
Here's the idea. Like if a tenant want to access any profiles from any pod, he must create an object firstly, and the name of this object is the same to the name of the pod he want to get the coredump from. And the cluster would check if this pod is existing. And the cluster would log the UID of this pod. So if the pod was delete, and like a new pod with the same name was created, the user cannot get the coredump from that pod because the UID has changed. Can you get my idea clear?
Yeah. Okay. So part of that, so there's a CRD for that, is there? So and that would have the RBAC to apply to say who's allowed to get the core dump.
Sorry, I didn't get you.
So for any given pod, for any given core dump for a pod, there's RBAC around your API call to control who can access that. So you don't want everybody who has access to that namespace potentially to have access to all of the core dumps.
Yes.
So where is the RBAC defined for the core dumps for a particular pod?
Like other object or API in Kubernetes.
Oh, okay.
Yeah. So you can use it like any other object or APIs in Kubernetes. So RBAC is the setting of RBAC is similar.
Okay. I get you now. Sure.
What is the object on which you do the RBAC?
What?
I was asking, what is the object on which you do the RBAC for this feature? Is that a CRD?
UID. Currently, we design it with the name coredump endpoint. We call it coredump endpoint.
Okay. So the RBAC would be defined on that?
Yeah, the administrator could control if user could access this object.
Okay, sounds good. Yeah, I'm looking forward to the document.
Okay.
Okay, so maybe we are we will share some today's document, and And if possibly, so the next meeting, we'd like to explain again, and yeah, let me think up more, and we are just updating some our implementation. Okay.
Yeah, that
So,
sounds good.
yeah.
We'll put you down for a follow-up next meeting.
Oh, thank you so much, Sasha. Yeah.
Thank you.
So,
Yeah. Cool. And then, so the next item on our agenda
okay.
is that we were going to have a presentation on someone that has a update to the tenancy CRD.
Hi, can you hear me? This is Kural from Intel. Yeah.
Okay, cool.
So let me put my proposal thing in the chat. I put the link actually, and I will share my screen as well.
I had a random question for you. Do you know how people can get access to that wiki to provide feedback? Because I asked a couple people and no one seems to know.
So the wiki page, it's just the Linux Foundation username and password. You can just log in with
Okay.
that. So it's the same thing what you guys uses for CNCF, right? It's the same thing. Anyone can comment on that one.
Okay,
Yeah.
awesome. Thank you.
So let me do a little bit introduction about our team. So myself is Kulamdar Ramakrishnan, and I'm working as a senior software engineer in Intel. So I have my teammate Itahan also here in the meeting, and we working on ONAP or Akrino project. So the ONAP is basically like a service orchestration. It's one layer above the Kubernetes, and when we have future request in ONAP for multi-tenancy, we are looking at the Kubernetes, whether the Kubernetes as a resource orchestration have the multi-tenancy future. And we were following this working group for a couple of weeks. For like 4 weeks, I am following this working group, and this working group is really very active. And they also did some kind of multi-tenancy POC work. So we thought we should will consume that work for our project in ONAP and as well as in Akrino in Linux Foundation. So we went through all the document, and also we had run the initial POC work, which is done by Sanjeev and his team. So this wiki page is basically a little bit explaining about the ONAP requirement on multi-tenancy, and also um, to show how the multi-tenancy works in Kubernetes. So the goal of this scope or the proposal within the ONAP is to work with the Kubernetes SIG groups or working groups, and we are not going to have any other different solution other than from this working group. And I also following this working group, there are other solutions as for multi-tenancy, where you have a separate control plane for each tenant in a cluster. We find it's quite expensive, and also it's difficult to maintain in point of for our project in ODAP or in Akrino in Linux Foundation. So we want to consume. We thought this project, the multi-tenant controller project, is very simple, and we think this is where we will head ahead to provide some kind of a future or a PRs to this project. And the recommend we had is our use case is so sorry, I have to reduce this one. Sorry. So our use case is basically from multiple users. We have telecom, com segments, and where the end user or basically like a tenant, and we want to track the usage of the resources of each tenant, and that is one of the use cases in ONAP and in Akrino stack. And we also make sure that what is the level of resource consumed by application also. And even if it's a application is running in multiple tenant, we should get that resource allocation and how many resources used, so that when we place a workload from ONAP or something, it should knows in which Kubernetes cluster it has to place that workload, and it has to also understand how many resource quota is available for each tenant in each cluster. So that is our use cases, and we have other use cases which is not much related to multi-tenant, but it's related to scheduling part. And we also want to create centralized. The fifth recommend is to create a centralized credentials for all the tenants and also the applications which will be running in ONAP, and then that will be passed down to Kubernetes. By saying that, I won't go in depth about the multi-tenant proposal because you guys are expertise on that. So all the materials which we put here, it's referred from the reference documentation which we provided at the bottom. So we are not the sole author for this one. We said that the document and all the stuff is related to the authors who have written the document in the reference section. So this section just to explain how to run that one. We just doing some kind of initial POCs on that, and this is what we want to discuss today. And we want to have a future request or a future which provides CRD for resource quota. And this resource quota is basically like bookkeeping, tracking, and discovering of the tenants actually. So it's just a wrapper for the resource quota which is already in Kubernetes. So what we are doing is like we accumulating all the resource quota of each namespaces and putting on top of the tenant, and we basically reusing the working group tenant controller, which is our aim to reuse it again. And and this is just a structure how the resource quota should look like. And in the resource spec, quota spec, we are just reusing the Kubernetes resource list and resource scope. So this is, as I said before, right, it's just a wrapper for the resource quota. And this is quite where we want to explain what is the tenant resource. So from ONAP or from Akrino side, we have these resources. So suppose if you have a tenant or a department or something like that, we'll say this much CPU or memory or the pods or resource they can use. So we are basically using device plugin called device plugin, which is open sourced by Red Hat City Office, and this is very handy. So once we able to be using it just for the experimenting purpose. So this basically this device plugin just give a dummy resource. So you can, instead of this one, you can introduce some other device plugins like FPGA, QAT, or GPUs, anything here. And so this is where you say like how many resources you are allocating for this tenant. So the CPUs, memories, and pods. So instead of pods, you can also say that how many pods this tenant can run in ONAP or something like that. And then we'll say how many resources it can use, like FPGAs or GPUs or anything like that. And then we will allocate the resource quota. This is what we introducing like a wrapper, and that wrapper will have the tenant. We reusing the same tenant namespace what is already created by the tenant controller POC, and where we specify each tenant CPU, memory, pods, and device plugin resources actually. So what we are trying to do is like we creating a one layer above that where you create like a, give us some amount of resources for this tenant. Within the tenant, you can divide it for each team or for each client, and we creating a pool like silver, gold, and this is per team. And the next one is per application. As I said in one of our recommend, we want to track how many resources this particular application is using. So our use case is basically on telecom and com segments, where we can want to track the resources of the VNF applications. So we just put like the firewall, what is the firewall quota of this particular tenant, and there we basically using the list which is already there in Kubernetes, and this list basically reuse the resource quota with the values. So you can, within the tenant, you can have multiple levels like v1, v2, and v3. And having said that, I think the diagrams will little bit explain more. So you have a tenant, and you have a team like gold, or the pool of customers who is the gold customers, and team of other customers who is like a silver customers. So the gold customers will able to use lot of resources, the silver customers used to use less resources. Apart from these two tenant, even you can run an application where we want to track this application with the different versions, right? So it's not that we just concentrating on the client or the user, but we want to also track the application, how much resources this application can run. So we want to do that. So in the example, we are just putting in the same namespace, but the application can run in a different namespace, and it can shared by a different tenant actually. So do you guys have any questions so far? Okay, I think no. Let me go.
Quick
Yeah,
question.
go. Yeah, go ahead.
How does the tenant spec up at the top for total resources spec.hard reflect the sum of all of the resource quotas defined in user resource quota list?
So I think the diagram will little bit explain more. So when the admin creates the totals, this one, right? He creates this particular, the first one, the overall tenant resource quota, and then within the resource quota, it will refers to this resource quota of the individual client or the tenants within that. And we proposing a kind of admission controller or a controller which will review whether this overall things is summing up or not. If it's not summing up, it will turn out to error saying that whatever you put it here, it's not summing to the resource quota you putting below this one. Is that answer your question?
Yes. So basically, you want the sum of all your namespaces resource quota objects to sum to be that spec.hard value.
Yeah, exactly. Yeah. So it's basically a bookkeeping, as I said, right? So it's basically doing the bookkeeping. It's not doing any kind of strong isolation. And but that the one more thing, it's also see whether this particular resource is available or not. When the user or the client try to run a pod or a workload, it also see whether this tenant can run this workload or not, because that's what basically the resource quota do in Kubernetes, right? So this one is basically like a wrapper to that resource quota, and it reflect the resource quota for tenant level. So it's a very
So,
logical unit. Yeah.
so does that mean that you have to provide the quota for each namespace within the tenant in addition to providing the overall tenant quota?
It's up to us how we want to take that one. So it doesn't mean that each namespace should have that one. If that is not, it will try to pick. For example, right, if you don't have this resource quota for this particular tenant, uh, we can put a logic saying that this is a common resource and this tenant will also use that resource actually.
So it's not
So,
sorry, go ahead.
yeah, just to kind of, I think there's a little bit more clarification on the resource management model needed here.
Okay.
If we are looking, so there can be a couple of ways. My initial expectation had been for this resource quota that there is a quota for the tenant as a whole, and it doesn't matter whether individual namespaces within that quota, within that tenant rather, basically it's a quota at the tenant level, and individual namespaces don't need to have individual quotas because they can share the quota, But
Yeah.
but in that case, that's a slightly different model than in which you have the tenant resource quota and you have the namespace resource quota, and the controller is simply checking that the sum of the namespaces is not greater than tenant quota.
Yeah, yeah, yeah.
But the
So,
actual enforcement in that case, in that second model, the actual enforcement is still happening at the namespace level.
yeah, yeah, yeah.
Whereas in the other model, so which of these two models is closer to what you're thinking at this point?
So for us, we are thinking at the both the models actually, and because the second model we are very much inclined, because that's where we can show this particular namespace as a resource quota. The first model which we are talking without the resource quota, it's kind of a second priority for us.
Okay, but I think let's again we'll review it more
Yeah, yeah,
offline.
sure,
We'll
yeah,
be able
yeah.
to give more comments. But I think what I would encourage us to think about is that if the controller is just doing the arithmetic of checking that the namespaces are adding up no more than the tenant, then it's not delivering that much more value, right? Because it's just saying, just it's really just a configuration checker really at this point.
Yeah, it's a configuration checker. Why we are doing that? Because we want to showcase that it's in overall it's summing up the value for the each namespace or each client or the customers using the particular end resources or edge cloud. And the first proposal you mentioned is without any resource quota. I think that's also have the values for our use case actually right now, but we want this first feature to be as a first feature request for us actually. But what we can do, we can able to provide the both the features actually. I will put the both the features in, include that one as well in this proposal. I can do that, yeah.
Right, and then let's have more detail. Let's because I feel that will kind of add a little bit more value, and then
Okay,
we'll
okay.
be able
I
to
can add that one.
provide some more comments.
So for that use case, right, you're saying that without any resource quota. So in that case, you see it's a common pool, and any tenant or the namespace within that pool will use that resource. Suppose,
Right,
yeah, okay,
right, and
okay.
also let's be clear in terminology, right?
Mm-hmm.
Let's not call within the tenant
Mm-hmm.
those individual namespaces as, let's not call those also tenants, because
Mm-hmm.
so to be clear on terminology, there's X number of namespaces inside a tenant,
Mm-hmm.
right? Those X namespaces are themselves not tenants, right? They're just namespaces.
Namespaces within that
Right.
namespace,
Right.
we can have a bunch of clients or the customers.
Yeah. Right.
So
So the thought was that could we have a tenant level quota which applies to the aggregation of the namespaces without the namespaces themselves needing quotas? Or,
okay, okay.
right?
I
So that
got
is
you. Hey, I
if
got
That
you.
would
you,
follow the OpenShift model with cluster resource quotas, but having some better aggregation of knowing and assigning namespaces to given tenants. Is that what you're requesting or suggesting?
so in the OpenShift model, it's one namespace per tenant, right? One namespace per project. So there, it's resource quota equals project quota. Namespace
Cluster
quota.
resource quota is something different that is a multi-project in that situation resource quota that allows you to kind of trade resources amongst multiple projects identified by a label selector for those projects. But our issue has always been ensuring that the right label is on those projects.
You're right. Cluster resource quota is different. I need to read up on that one. So the bottom line is that let's be clear on precisely which model we are going after here in this.
So
And
what I see is that so I put like only two use cases or the two models I had. So your model is like I have another NS4 namespace which is doesn't have any resource quota, and what will happen that scenario, right?
right. In that
Okay,
case,
okay, okay,
now
okay.
I'm not saying we have an answer. I'm just suggesting that we think about it, right?
Yeah,
Maybe
sure, yeah.
because
So So the way I understood it is maybe, so are you, I'm talking, I don't know who was talking, but I'm talking to the person who is presenting the slides. Like,
Yeah.
do you assume that the resource quota always exists in each namespace?
So for our use cases, they exist because we have to do
Okay, got it.
hard.
Okay, I think, yeah. Sorry, I was going to say that I think that makes, I mean, yeah, so I got your understanding, but what makes more sense is that for us to be like able to define across namespaces, and then
Mm-hmm.
maybe the implementation is that you actually go and create resource quotas per namespace, which divides the whole aggregate across these namespaces equally, and then creates a resource quota per namespace. So that could be an implementation detail and one way of implementing it.
Yeah, I think that will create multiple scenarios, right? If this
No,
particular,
I'm just suggesting. So
yeah,
it may
yeah.
not be a good implementation, but I think I think I agree that it would be good to have a mechanism which basically creates one per tenant, and then
Mhm.
somehow it gets implemented or
Yeah.
enforced across all namespaces within the tenant. So
So in this case, as you said, right, if the NS1 and NS2 have the resource quota, then you will have the resource quota allocated for that. And if NS4 doesn't have any resource quota,
Mhm.
we have to see the scenario like whether we have to create a resource quota for the remaining resources matching to the NS4, or in future if someone create the new namespace or NS5, right, how the sharing should be.
right.
So yeah, I think there is multiple scenarios, and the third scenario what we are targeting is the per application actually. So the application could run in the same namespace, or it could run in the multiple namespace with the different priorities or resource quota. So that also we are targeting, but I we will take the both three use cases, and I will include that use case you guys suggesting here, and I will rewrite this one. So the one question I want to ask is that is this you want this proposal to be here, or we can move it to the Google Docs and add it in one of your proposal actually?
Yeah, so Kurul, yeah, we can definitely add it to one of the existing proposals. So I just feel like we need to
Mm-hmm.
define it a little bit more precisely for now.
Okay.
And so let's keep it as it is right now. Let's have a little bit more review by the working group over the next couple of weeks.
Okay.
And really, my at least my individual thing, and I'm sure others have their own thoughts as well, is that um, the primary value of resource quota per tenant would be
Mm-hmm.
if individual namespaces don't need quotas, but you still have a fluid pool of quota for the tenant as a whole.
Okay, I got you.
So
Okay.
let's think about that. And, you know, there are implications in terms of the runtime. Does that actually map into the underlying C groups of the runtime or not, right? So there's a little bit more analysis we should do.
You
And
mean
we can certainly merge it in as appropriate. This is obviously very much affiliated to the controller CRD.
mm-hmm.
Let's evaluate exactly the model here, and we can then we can merge it as needed.
Yeah,
So
I think there's actually still there's a fourth level of grouping here,
mm-hmm.
similar to the is it just exactly the same? Do you take the whole tenant if they've got 5 namespaces? Do you just split it in, and you've got a tenant quota? Do you just put 20% of it in each namespace? There's a whole other level of grouping here, because in our situation we have a tenant it's not just one kind of, when you have the concept of environments, so you've got dev and test and integration test and staging and production and stuff like that. So the controller we're building actually has, well, there's a bunch of things, but it's I can say my app when it's in, or sorry, my dev environment has a certain amount of resource quota, and maybe it's 8 CPUs and there's a total PVCs of 20 gigabytes in dev, but in prod it's actually 100 CPUs and can use 4 terabytes in prod. That I'm still a tenant, but I have multiple environments within my tenancy. So that, you know what I mean? There's another level down of specification of, it's not just, there's just a homogeneous set of namespaces that make up the tenant. They can be grouped at another level of abstraction.
Yeah, no, I totally agree that we definitely should not assume that, you know, the quota is divided equally amongst all namespaces. I think that's overly simplistic. What we really want is statistical sharing of that resource across all namespaces of that tenant. The model here is, at least in my mind, is that the tenant is the one getting charged. Okay, so the chargeback is based on the resources that the tenant as a whole uses. It doesn't matter whether namespace A uses 20% of it or 30% of it, or it's totally fluid and dynamic. What the chargeback model is that this is a tenant and he's going to be charged on the quota of the tenant, regardless of the individual. So it's like, so that's at least the way I've been thinking about it. And certainly, you know, we can look at all different options here. And so all those other models of saying, okay, let's just assume it's divided equally, I think those are probably not, I wouldn't sort of consider them to be useful. So we need to have a couple of options here, which we can, you know, and then we can provide comments on the doc offline, and we can come back to it in the next call.
So,
Okay, so Sanjeev, you're just thinking of this as a billing construct then?
Billing is one of the implications of it. The reason you have resource quota is because you bill for it, right? So, you know, tenant A has, you know, a quota of, you know, X CPUs and Y memory, and maybe these can fit some profiles and on later, and so he's going to be billed on it, and so.
Sure.
Yeah.
We kind of put quotas and limits all together, so it's also.
So I think the other use case is definitely one namespace not using up everything that was allocated to other namespaces, right? So other than billing, there is more to it. Does that make sense, or?
See, the point is that if you want to have, you can additionally want to have namespace quotas, but that's more because you want to have some fairness within your tenant across, you know, applications using namespace 1 versus applications using namespace 2. So I give it a quota so that I ensure some fairness. I want to get, at least I want to get 20% of the CPU, right, or something like that. But in terms of what is the resource consumption of this tenant, that's the tenant quota, the tenant limit. By the way, that's another question. Like, are we including both quotas and limits at the tenant level? I would assume yes, right?
Yeah.
Okay. So that at the higher level, that has implications for billing as well, right? So, but let's you know, think about it offline and kind of have some comments.
So
and
what I will do, right, I will create some scenarios for the NS4, which is without the resource quota, and I will put like multiple scenarios and the use cases. Like, I think we discussed over like 4 models here. I will put all these 4 models. We only had 2 models. I will put all those 4 models, and you guys can comment on this page. Actually, it's the same CNCF for Linux Foundation.
So does it make sense to put it in a doc? Wouldn't that be easier?
We can change it. Yeah, I can change it in Google Docs and I can share it then. Yeah, I can do that. Yeah.
Yeah, I mean, if others also feel the same way, I feel like.
Yeah, sure. I will do that both. Yeah. Cool. Thank you.
So I have a high level question. What's the so we have tenant CRD and there's tenant controller. Like, is this what state is that in? Like, is that has that been reviewed and agreed upon, and is that part of the incubator, or is this?
So that was a POC, right? What we did so far was a POC. Actually, that we'll have that as an agenda item in the next call as well, where we will review the state of the tenant controller and sort of what needs to be done to make a more official version of it. Because right now it's just a POC, right? And there are some open questions there as well, like the namespace naming and things like that. And then this resource quota thing will also come into play there. So yeah, so that is a POC right now. It is open for comments. If somebody has any concerns, showstoppers, you know, just add comments on that against the GitHub POC, against the GitHub repo.
Is there
But
a
what we'll do
doc
is
also, or is there just?
yes, there's a doc as well. There's a
Got
doc as well. So yeah, you can look at the docs page in the links, and you'll see the docs as well.
Okay.
And you can go back and refer to our talks from last KubeCon on the deep dive where we went into that demo and all that. So the status of that is it's a POC. It is a working proposal. It is by no means final. We need to have a plan for the final, a little bit more official version of that. So in one of the upcoming calls, one of us, maybe myself or one of the others, we'll have an update on that in terms of the official direction for that controller. So it's still a work in progress. So feel free to provide your comments, but we'll bring it up in the next call in terms of what's the next steps for that.
Sounds good. Thanks.
Thank you.
Cool. Okay, I think that's it for today. So thanks everybody, and chat soon.